a little bit of the contents. We'll have to try to put it into context with Frontend, and then we'll look at Scala.js, which is how you do Frontend with Scala most of the times, and also some more advanced usages of it. We'll go through that, and then a bit of the roadmap as well and future plans. So the scope of Frontend. It all started with this question of one of my colleagues, might be in the room as well, who's a backend developer but hasn't touched or built a website for a decade or more. And I have some ideas for web apps I would like to test. How can I get started? So you post that on Slack, and then 15 minutes later, you end up with a huge discussion of hundreds of links and references, and everybody's is giving a different answer. You should use React, or you should use Flutter, or you have to do that this framework or this other one. There are hundreds of responses. So just after a few reading a bit the threads, you end up in like a lot of ideas. It's all those technologies, they are in some way used, and in some big cases or small cases, but they are interesting and there for a reason. But after an hour of reading, you just back to square one. I still don't know how I should start, where I should go. So I asked ChatGPT to try to sort a little bit what was Frontend, and came up with this this table, where at the bottom you see that you have more the classical websites from 20 years ago, where you just do HTML and CSS and nothing else. It's very static websites. All the way up to the first line, where you do have really native mobile apps. And just to talk a little bit of what we do at Wolt, Thomas was talking about the 3 different apps we do. We have actually the consumer app. That's the one where you want the best experience. So we have really native apps for that. It takes more resources because you need to do one for iOS, one for Android. So we have, at the moment, Swift for iOS and Kotlin on Android. And then on the Courier app, at the moment, we have React Native, which is a bit more, you have just one code base, but then you can cross-compile to have it in both Android and iOS. It gives you a very good app as well, but not as close as a consumer one. So I think we have some steps to migrate at some point to it, just like more resources. And then the third category is the merchant app. That's where you want to present, if you're a restaurant, you want to take orders and know when your couriers are coming to get the pizza, for example. And this is mostly tablets or iPads. So in that case, our merchant app is done with Flutter. Flutter is a framework that's built on top of Dart, which is not JavaScript. It's another language. So it's more niched, but at the same time, you can get a lot of support for making those apps as well. So we have, at the moment, also this technology in-house. And actually, where I work, although I do backend, and we touch the Courier app, but we also do take care of third-party fleets. That's fleets of courier. If you don't want to employ the couriers yourself at Wolt, you can delegate that a bit the same way as you do consulting. You have this pool of companies who have their own couriers, and some of them, I mean, they have really like hundreds or thousands of couriers. But since it's split in all those 30 countries, they have many different ways of managing them. And most of the time, they don't really know where they are or how they should take orders. So that's why we have done a portal to track where they are, how they perform, if they are active or not, if they are trying to cheat by hiding from work, or those kind of things. And this is a single page application kind of app we're doing with React. That's where you could have the case for Scala.js mostly. Just a small history timeline as well for Scala, going more specifically into Scala. Scala is from 2001 or 3, or some of the first releases. And in 2006, you already had those frameworks like Lift. It was very advanced at the time because you could already do multi-chat applications with Scala actors going in the browser. So it was compared to other Java frameworks in a bad way, that maybe the code was not very easy to read, but you had a lot of functionality that you couldn't see anywhere else. Then came the Play framework, which was supposed to be like a bit of the Lift framework, where you do server-side rendering. And it was also very popular. It's still popular because it's still active. It has gone from a company to type-safe, Lightband, and now it's open source, I think. But it's also on this journey, it has split the backend from the front end. At the beginning, it was server-side rendering only. And now they have extracted the template engine to run the server side. So it's more like pieces that you can, and you can do pretty much what you want. At Volt, we actually have a lot of the backend part of it of Play still in our system. So in 2013 came Scala.js, which was a PhD student under Martin Odersky, who was Sebastian Doran, who was trying to compile Scala to JavaScript with Scala 2 at the time. And he did that very well with maybe an executable that was quite big at the beginning because we were including all the Scala libraries into it. But as time passed, it was very optimized, and you could really write Scala and compile it to JavaScript. Then came other small frameworks built on Scala.js. Slinky is one of them that I thought was interesting for a while because it was very, very close to React. The code looked almost the same. It's just that I won't talk too much about it because I think the project doesn't have so much traction anymore. People are maintaining it, but just there's no activity really the past 3 or 4 years. Then more recently came other frameworks, and we'll go more into deep with them, Laminar and Tyrian. Then Scala.js, Scala was rewritten, the compiler was rewritten from Scala 2 to Scala 3, just from scratch. So at that time, Scala.js could have a new story as well. And we'll see that in a moment. So most languages compile to the JavaScript, actually. You have all those lists. I won't go through it, but why not Scala as well? And in the Scala 3 compiler, you can see that now that you have some sort of intermediate representation of the Scala source code, you can target the JVM, which has been the case for 20 years. But now you can also target Node, for example, or even native code. So if you have embedded systems, you can compile Scala to LLVM or some other VMs. So now getting starting with Scala.js, if you want, we are going to switch. Here it was a slide just to start with something. Vite is something that usually people who don't work with Scala can use. It's more like a server for developing and running JavaScript applications. It has a lot of different kinds of framework it can use and variants of it. And it's very easy to set up. The only thing you need to install is this Node Package Manager, NPM. That's a minimal step. So let's try to do that. And for that, I'll open a browser and IntelliJ. So if you run this first command, the only thing you get is a JavaScript project. Here, there's no trace of Scala at all. And you can probably just run it. It starts a server, and then if I do that, that will render it. Oh, I lost my IntelliJ, but it's just reloading the page whenever you are changing a code. But here, there's really no trace of, I mean, there is a counter, but it's very simple JavaScript application. Now I will try to change branch to Scala.js. Oh, it's no problem. I think it's just crashing because we have to build something. But what do you do then when you want a minimal Scala.js project on top of that? We can just compare. Let's just do a git diff with the main branch to see what we've added with here. So you see there's not much difference. There is this class. That's nothing. It's just a Scala, the SBT version. The plugin, the Scala.js plugin, one line. Then instead of all this JavaScript code that you saw at the beginning, you have a main executable, the same thing that you would see in Java as well, and where you reference this DOM, the document object model. That's the only thing you need. The DOM is just a graph where you have all your HTML components attached to it. So if you're writing a single page application, you just hook up those elements and then you render them. So with this just one line, you just attach this node to the main app, the root node, and that's how you start. The rest is just in SBT. You need just very few settings. I took those from Sebastian Doran's examples. There are plenty. By the way, you can use Vite, but there are also many alternatives. You can use Parcel or Snowpack, or there are many other ways. And the only thing you will have when you have compiled, or maybe you don't see so well because of that, but it's just import of the executable instead of the JavaScript code. So let me try. So I just run SBT. And to compile the code, I'll have to that command. There are several options. Opt is one version that is very much for development because it's not optimized. Link.js is also, I'll even run it with this tilde to make it continuously rerun. So it's compiling, optimizing, and here you go, you get this code online. That was not so many things to configure. I just close those things. So out of this code, that's where I can even remove that. As soon as I save, just shows up in the browser. Very simple. There was not that much to do. So let's go and continue a little bit. I'll just change branch. So I'll get out of that. And now we'll try with Laminar. Hello. I have to put away the stuff that I changed for us to be able to change branch. I can just present a little bit Laminar as well in the slides first. That would be useful. So I'll go back to pretty much where we are. Which is here. So once we've done this getting started experiment with Scala.js, we want to develop something more useful, a bigger app. That's where we want to use other frameworks. And the two that I was mentioning before, Tyrian and Laminar, are the one we are going to compare a little bit. On top of that, since we don't want to rewrite all the great ecosystem that is already in the front-end development with TypeScript and the people who are using React, we want to have a way of reusing all those components. And that's where it's very interesting that you have this Scala.js typed library or plugin that is able to generate all the bindings from TypeScript from any component. We'll see also an example of that, trying to do a chart from a JavaScript library. The interesting part is that JavaScript is a dynamic language, so you can't get all the types from it. But at least having a facade, then you are back into Scala, where you can do all the manipulation of Scala and Scala 3 and use all the Scala library as well for your processing. It's just that when you need those components, you can use those produced facades. Then there are some people who have been writing cool web components out of Laminar or Tyrian so that you can also integrate them in a better way. As well, there is also, if you are not just satisfied with a web app, but you want to run it on a mobile, on an Android phone, for example, or on an iOS, you can use also some runtimes like Capacitor or Ionic. There are different ones. And there are examples of that I mentioned, where you can, out of your normal web app, produce something that is more native. So if you want to use geolocation, for example, from your iPhone, then you get that information. It's still not the totally native experience, but it's kind of quite a bit equivalent to React Native. I've seen there is this site that's called Scala Times online that has a lot about Scala all the time. And this week there was just an article showing an Android app built that way with both Tyrian and Capacitor. So Tyrian, it's closer to another language called Elm that is also used in the front end. That's also 12 years old now. And where you have this model of very close to React. It has inspired React with this architecture where your state is an immutable model. And then it's just events that are coming that will re-render the page by just propagating the event. But since the model is immutable, you don't get a lot of those inconsistencies in your UI. So it's unidirectional. So that means that whenever you get new events, you will re-render your model. And that will trigger the rendering of the whole page wherever you use that model. Just to show a simple example, it's one of the good features of this Tyrian or Elm is that the code is very, very clean. You don't have a lot of fancy things. It's very, you have this view where you render your components. And then this update of the model. It's very close to React as well, the way of programming of React. Laminar, the other framework, is built totally different. I mean, the output will be the same, that you also have components and you render them, but it's based on a reactive programming. It's observables. It's also in the Java world. It was used quite a while with RX in Java. I think Netflix was using that for a while a lot. And where it's a bit different because you are not re-rendering the page with the DOM that you diff with a virtual DOM and re-render the components. Instead, you are hooking directly observables. It's more like subscription mechanisms where you hook observables to the nodes where you want to have this dynamic information. And so those variables, the event bus, you can write to them values. They will change. And this state, which is immutable, the signals, for example, you can read those values as they are updated. So mechanisms, since it's not touching the DOM, I think I have a slide to show that after. But just to look at the code, it's also very similar where you have this render method that renders your HTML. You see that all those divs on the slides, div or label and input, they are those components you want to render in the page. And they take as arguments functions. So even the hello at this code is also, it looks like a string, but it's actually a function. It's a modifier. And you can solve that by using implicits. But every inside element will be a function where you can do, you can set properties. So for example, placeholder is a property. It's a setter. But since they are all returning functions, you can really add them one after the other. And you get a lot of very convenient functionality. Those kind of arrows of syntax, it's a way of putting values into those vars, those observables. That's how you work with observables. It's also very little code, but here, this laminar hello, it just, you provide input and you get output in your hello node. You can, just before going to IntelliJ, just so the slide to compare both of them. One is done with, as I said, comparing the virtual DOM to the DOM, which is also what most frameworks do. The other one is directly touching the DOMs, the nodes. So it's very efficient, except you have to, the first time you load the page, those could be an operation that takes a lot of time. That's why in the other example, they were using the virtual DOM instead. But so it's two ways of doing it. But in the end, Laminar was thought more about speed, that you could precisely update some specific parts of the DOM, whereas Tyrian or React base was more about diffing what has changed and re-render the whole thing. So it was maybe a bit easier to reason about. The code is a bit more like regular TypeScript or what you would do with React. But in the end, you see that when you dig into documentation of both, that they're actually not really that way. React is quite fast, and the Laminar is also very easy to apprehend and to use. I have to speed up a bit. One of the interesting, I'll go a bit with the slide first and then just once with IntelliJ. One of the interesting usage of Laminar is that you could do UI derivation. I haven't invented it. It's already been presented by, among others, Kit Langton. He was doing a talk about it. I'm also having a reference at the end, where it's a very interesting use case. You know, in Scala, you have case classes. And so the same way you can do JSON derivation to produce JSON back and forth, you can do that for other things, like creating your UI automatically out of a case class. And you do that. He was doing that with Scala 2 and some external library, Manuela. But you can do that directly with a Scala 3 metaprogramming. That is, you start having access to your case classes. So you can recursively decompose everything from the fields of the case class and render each component out of that, which is very powerful because you will get a UI that is quite boring. It just follows your case class or your abstract model. But in a lot of use cases, you would like to do that because it takes you much less time to create your UI, especially if you do some admin. For example, at Wolt, we have Ops tools, which is a tool for customer support. Those kind of UIs, you don't need to make them very fancy and animated. In that case, on the main class you see on the right, the only thing you have is that this derived courier, in that case, you don't have to change anything in the code. Each time you will just edit the classes and add parameters or different rendering, it will produce the UI again. So We'll go there in IntelliJ. Oh, the Laminar Hello, we don't have that much time, but I showed it on the slide. You can try it. I will also give this GitHub repo so that you can experiment more. But I think the UI derivation is a bit more interesting. So here I just compile it again, SPT. Starting it. Here you go. I can do it a bit bigger. So here I just have a form where I can fill with all the components of my case class. If you remember, the case class look like this. So if I would add a field like this courier is allowed to book shifts, the shifts they are at the time you spend when you're online to work. So if you put here a Boolean, I'll just save. Then suddenly you get a checkbox where you can see that it's changing also the output. So the form you submit is changing. If you type another name, Alice, then you see the case class is updated. That means that you can pretty much, even using probably, it's not implemented yet, but even using options or lists, you would be able to render any kind of tree. Normally, when you have those abstract data types that describe your model, you have two things to consider. You have product types or sum types. They're also called coproduct. Product types, they are like case class. That means every parameter, all the values of those parameters, you can multiply them to know the number of possible states of your case class. Some types, they are more like enums. So in that case, if you have a vehicle type that is bicycle or car, you have 2, 3 different possibilities. And you call that a sum type because all those possible states, it's just a sum of those. But having both, you can probably create very fancy UIs to represent any kind of domain logic. So that was for it. I also have a demo. Let's see if we have still just a little bit of time. If I go out of there, I'll try to do the Scala type just to show one of those. Check out to remove what I had. Like this. Oh, here. It went directly, changing the styling only. But I have to recompile as well. Yes, now my case class, it's different. It's using those bindings generated by TypeScript. It's this chart.js library where we have a bit of code, but it's the same principle. You can look at the repo. And the rendering is using those charts, the rendering of it. There is already a repo with a lot of the bindings they've been compiling. I mean, they compile them quite often. So if you don't want to run the plugin on each time, you can also use them directly. It's a huge repo where you have pretty much everything you can think of. So that was, and just some last words. So scalability types, that's just what I showed you. So in the end, I think, if I run the show again, in the end, what I think as a pros of using Scala.js is that you have a very good stories whenever you have a complex query to implement. Because normally it's easy to start with React and JavaScript, but after a while, when you need a lot of refactorings, that's where you start to lose track of, you change something and then suddenly you get undefined everywhere and you have a lot of problems. So whenever you have really a huge use case, it's very nice to use Scala. There is an example also, there is this site rock.jvm, which has a great material online to learn Scala, both backend and frontend, but it's using one called the Rite of Passage, which is quite a big application written with Scala.js and with Tyrian, I think, but he also has one with Laminar. And you see much bigger applications with component and validation and other things and authentication, so that you can build something quite useful. Also think that most of the time in the JavaScript world, you have tons of small libraries to solve particular problems, like how to handle validation or options or a lot of things that are already in the Scala language. So you gain a lot of not having all those dependencies and updating them, and it's really time consuming. Also, you have those things with capacitor. You can use the more like the capacities of the targeted device. So as I said, there was this link online of Scala Times. You can read more about it. The cons of Scala.js, of course, it's mostly that it's a very small community. Those frameworks are one-man framework, most of them, both Tyrian and Laminar. They are maintained well, but it's just one person plus a few contributors, but you really have the risk of maybe you're not sure about how they can evolve. Although they've been extremely great technologies to use as far as I can see. Then there is another thing, if you think of the roadmap, is something that's called WebAssembly. It's quite getting popularity as well. I know from the beginning, it's mostly like a Rust thing that you can compile to something that is more than JavaScript, that is closer to the hardware. It's called WebAssembly just because assembly language was really close to the hardware. And in 2019, Sebastian Doran was doing a talk telling that it was almost impossible for Scala.js to compile to WebAssembly. And mostly because Scala is a garbage collected language, runs under this JVM, and there was no specification to handle that case. In the Rust model and the WASM model, you have linear memory, so you're not taking into account objects or type references the same way. So there was no really a good way to do that. But since that time, a lot of things have happened. Now you have support in browsers. So a month ago, I think he and some other people, they have done this integration to be able to compile to WebAssembly, which is great because now also Scala.js has a story for WebAssembly. In a lot of complex applications, you don't really want your browser to go around your disk. And so the sandboxing of applications makes sense a lot. Also because browsers, they can be embedded in a car or a lot of devices. So this WebAssembly has a lot of good things. And it's also from the beginning, you think it's about a lot of the speed you gain with WebAssembly that you want to compile to that sort of format. It's still to be seen how much you gain into speed doing that from the Java perspective, because since it's because of this garbage collection, you don't have really this linear memory model anymore. So you might maybe not get all the same speed as Rust, but at least you get so much more productive by writing Scala.js rather than a very low level language as Rust. So it depends on your use case. So my conclusion is that there is very much untapped potential in Scala.js, and it's really, I hope you can see by yourself, and there is some good material of a small community, but very good use cases. That's for me. I'm not sure we have so much time for questions, but otherwise, I mean, we can make a break and I'll be happy to answer. Thanks.